बच्चों, we were discussing the part in project management. In project management, we were discussing the last time we discussed the critical path, CPM, critical path method. In last class, we discussed this critical path method. Today, we are going to discuss the part. What is there in a part? Moreover, what is the expansion of this part? Let us deliberate on this one. Program evaluation review technique. Program evaluation review technique. And we have already discussed the difference between the PERT and CPM. I take few of the cases out of that one, PERT and CPM. And then we'll take one problem related to that one. In PERT, it is based on the event or node base. This we have already discussed in the last class, and this is the activity base. This we have already discussed what is the difference between the event and activity. I take one example later to that. There are two circles. When they are joined by one path, this is known as activity. Clear? And these two circles, these are known as event or node. Clear? Here there is a three-time estimate. This is the important part. Three-time estimate. Three-time estimate. This is the single-time estimate. Single-time estimate. And if you look at here, when there are three-time associated, let us have a one diagram related to that. This is basically a normal distribution curve. In normal classes, it is not going to touch. You can go up to infinite, still it is not going to touch. So this is the time, this is the optimistic time, TO. And this time is known as most likely time, TM. And this is known as the pessimistic time. This is known as the pessimistic. There are three times associated with this one. So basically, this is based upon the probabilistic model. Probabilistic model, because there are three time associated. So far we are not confirmed in which is the suitable time out of the three. We'll deliberate on this one. And this is the deterministic in nature, and moreover this is the deterministic model, and there is a single time associated. Means there is only one time which is associated here. So the deterministic model. So let us deliberate on today this one. We are going to discuss the part. In part, there are three time associated. In critical path, we have already discussed this is a single time associated. Now we'll discuss this three time associated. Or out of that one, we are going to calculate the single time. And you will always consider me will calculate the expected time. We calculate the expected time. And how to calculate the expected time? There is a formula for that one. There is a formula for that one. You can write down small t, capital E. This is the expected time. Clear? T naught plus 4 times Tm plus Tp upon x. There is a single time associated with this one. So this is called the expected time. Once we will calculate the expected time for all the activities, means we'll have a one unique value for each activity. Let us deliberate, or today we'll calculate this thing. Another thing, we'll calculate the standard deviation also. We'll calculate the standard deviation also, because what is the dispersion which is there means if I put it like this one also, If I this dispersion, again this is TO, this is TM, and this is TP. Clear? Again we'll calculate. And here if you look at this part A and the part B of the problem, this is more expanded along the, this is the dispersion path. So this is another important data which we will calculate. For calculating that one, there is a standard formula, that is sigma square. This determines the sigma decides your this standard deviation is equal to TP minus TO upon 6 and whole square into the whole square. This is the standard deviation. And what is variance? Variance is equal to sigma square is equal to TP minus TO upon 6 into whole square. These are the two things which are important in this one. So we'll take one problem related to that one. I take one of the diagram related to that one, and we'll calculate only TE and variance today. Today in a part problem. So we'll discuss only this part today. So later on we'll calculate rest of the things. So I take one problem related to that one. We'll discuss that thing. So once we know this, we rest of the procedure will remain same as we discuss in a critical part. That we will discuss in a subsequent classes. So I take one problem related to that one. Let us have a problem. This is given to you. This is given to you. I take a problem related to that one. You will calculate that one. This is given to you. This arrowhead, this is given to you. And with another one. This is the another one. This arrowhead is given to us. This is given. And moreover, in a multiple of 10, 20, 30, 40, this is the numbering system which is already given to us. We have already discussed in the Fulkerson in last classes. Today we are not going to discuss this thing. So this is the value which is given to us, 6, 9, 12. There are 3 time associated. This is given to us, 4, 7, 8. Then 3, 5, 9. This is given to us, 9, 11, 12. This is given to us, 7, 10, 13, 14, 17, 20. This is given to us, 13, 18, 25. This is 12, 15, 18. This is 10, 14, 16, 17, 20, 25. Now, this is given to us. The 3 times are associated. This is given. It is given in order of T0, Tm, and Tp. It is given in this order. What is TO? This is TO is nothing basically optimistic time. Optimistic time, the person, let us assume there are 3 workers. Those who are working for the activity 10 to 20. Similarly for 10 to 15, and similarly for rest of the activity 20 to 30. So optimistic means this is the minimum time out of the 3. That is called the optimistic time. And the most likely, if a person do at a normal pace, means if a person is moving at a normal pace, this is the most likely time. Most likely time. Mean if a person is doing at a normal pace, means he is not doing the activity in a hurriedly manner. So this time is known as the most likely time. We always pay more attention to the most likely time. Another thing is the pessimistic time. If the person is not giving due respect to the time, means he is just wandering here and there, and he is not doing his duty rather sincerely, So this is the time, or sometimes he is not aware of the situation. He is not means how to do the activity. So that is the time that is known as the pessimistic time. So this is the order TO, TM, and TP. So we'll calculate the single time associated for R. So we already know the formula. What was the formula? TE. This is the expected time. Means out of 3, we'll calculate the one unique value. Only then we will proceed further. Considering all the optimistic, most likely and pessimistic. TO plus 4 times Tm plus Tp upon 6. Clear? Now I know 10 to 20. Then I know 10 to 20, then 10 to 30, 10 to 50. This is the one activity. Then 20 to 50. This is another. 20 to 50, rather 20 to 30. Then 20 to 40, it is given. Then 20 to 50, it is given. Clear? Then from 30 to 70, we'll calculate this one. 30 to 70, this is the one activity. Then another one is we'll calculate 40 to 70, 40 to 60, then 40 to 70. Then we'll calculate from 50, there is only one activity, 50 to 60, and from 60 to 70. So these are the activity 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the time given to us TO, TM, TP. This is given to us. 6, 9, 12. This is given to us. So 10 to 20, we'll write down few of them. Then 10 to 50, this is 10 to 50, it is given. 4, 7, 8, 20 to 30, it is given. 3, 5, 9, 20 to 40, 20 to 30, sorry, this is 14, this is 14, this is 50 actually, not 30, this is 50. Don't get confused, this is 50. 14, 17, 20, 20 to 40, this is given 7, 10, 13, 20 to 50, it is given 3, 5, 9, 30 to 70, 13, 18, 25, 40 to 40 to 60, it is given. 40 to 60, it is given. This is 12. Rather 40 to 60, this is given 10, 14, 16, then 40 to 70, it is given 12, 15, 18, then 50 to 60, 9, 11, 12, 60 to 70, this is given 17, 20, 25. Now we'll calculate the expected time, we expected time, that is equal to TO plus 4 times TM plus TP upon 6. We know the formula. So we'll calculate the expected time for each activity. This will be one single unit in a. So what is there? If you look at here, 6 plus 4 times 9 plus 12 over 6. So if I calculate 6 plus 36 plus 12 over 6. So this becomes 54. Is it okay? 54 over 6. This is equal to 9. Clear? Similarly, 4 plus 7 into 9. Sorry, this is 4. Oh, sorry, 4. This is the optimistic time plus 4 times into the most likely time plus 8 over 6. If you calculate this value, this is 4 plus 28 plus 8 over 6. So this value is 36, this is 40 over 6. Clear? So this is not a whole number, you will get something value 6 point something. So here it is 14 plus 4 into 17 plus 20 over 6. So once you will calculate this value, this is 14 plus, this is 68 plus 20 over 6. Clear? So this is gone 88, this is 88 plus 4, this is rather, this is 88 plus 14. This becomes 102. 102 over 6. Again, Whether it is visible, you can check it. Similarly, 7 plus 4 into 10 plus 13 over 6. Clear? What we are going to do, we multiply this by 4 and add both the values, extremities, value TO plus TP. You will get a unique value and divide by the 6. This is 7 plus 40 plus 13 over 6. This becomes 50, this is 20, this is 60 over 6. So again, this is the whole number, this becomes a 10. So you will have a unique value at the end of the day. 3 plus 4 into 5 plus 9 over 6. So similarly, 13 plus 4 into 18 plus 25 over 6. You'll have a one unique value. Do the calculation. 10 plus 4 times 14 plus 16 over 6. Clear? 12 plus 4 into 15 plus 18 over 6. Similarly, 9 plus 4 into 11 plus 12 over 6. We'll have a one unique value. It could be a whole number or it could be a fraction also. But try to have a whole numbers. But try to have a whole numbers in a real life situation. If it is a fraction, definitely you can calculate, but it will take a little bit complex, means it is more time consuming. So this is what we have calculated the expected time. We'll go with one more value. Similarly, we'll calculate the standard deviation or variance. This is nothing, sigma square is equal to TP minus TO upon 6 over whole square. Basically, if you look at here, basically I rub it here and I put it value here. Means this is called a standard deviation or variance. Means when we are calculating the critical path, this is another important part. And here if you look at here, this is basically variance is equal to sigma square is equal to TP minus TO upon 6 whole square. If you look at here the most likely time has been ignored, only the pessimistic and the most likely time has been taken here. And here if you look at the first one, this is 12 minus 6 over 6 whole square. Can you simplify it? This 6 over 6, 1 square is equal to basically 1. I just calculate one value, this is 1. Similarly, 8 minus 4 over 6 into whole square. You will calculate, this is 4 by 6, 2 by 3, something like that one. So you will have a 2 by 3, 4, 2 by 3 is 4 by 9 actually. You will have a value like this one. Similarly, this is 20 minus 14 over 6. Means we are pessimistic time minus optimistic time divided by 6 into whole square. This is 1. Similarly, 13 minus 7 over 6. This is whole square. This is 1. Similarly, 9 minus 3 over 6 whole square. Again, this is 1. 25 minus 13 over 6 whole square. This is 12 by 6. This is 2. This is 4 here. And here it is 16 minus 10 over 6 whole square. This is 1. Means if I take that 18 minus 12 over 6 the whole square. Again this is 1. 9 minus 12 minus 9, 12 minus 9 over 6 whole square. This is basically 3 by 6, 1 by 2. This is 1 by 4. Similarly, 25 minus 17 over 6 whole square. Basically, this is 8 by 6 whole square. This is 4 by 3. This is 4 by 4 by this is 4 by 3. This is 4 means 16 by 9. This is you get the answer 16 by 9. So these are the two values which we calculated today. We just focus on in a part. Again, I am what we discussed today. We have taken a one problem related to the part. In part, there are 3 times associated, which is given in the order of most like optimistic time, most likely time, and pessimistic time. And we will have a one unique value that will be in the form of the expected time. And corresponding to that, we have calculated the dispersion also, means the variance also. So we'll use, today we have discussed that two things, expected time for the each activity and the variance for each activity. Later on, we will use it for finding out the critical path. That's it from my side. If you have any question, you may ask me. Otherwise, thank you very much.